Question 1. Ask how many moles of oxygen atoms are in 25.7 gram of calcium sulfate? So tell us mass. Here are some mass. Ask moles of oxygen atom. So mass convert to moles, right? I wrote at this place many times. Mass divided by molar mass. You get moles. If you know moles want mass, then mole multiplied by molar mass, right? So here tell us mass of this compound. You need RC moles. Whatever moles, you need to find the moles first. So mass of this compound divided by molar mass. You get moles. What is the molar mass? You need to take a look period table. So take a look period table. Calcium 40.08, sulfur 32.06, oxygen 15.9994, just 16. Add these atoms together. This will be the molar mass. So calcium 40.08, sulfur 32.06, oxygen 16. This is the molar mass. So we find the moles. This is not your final answer because here asks you how many moles of oxygen atoms. And here we only get moles of calcium sulfate. For this formula, every 1 mole calcium sulfate, you have 4 more oxygen atom, right? So you need 1 more step times 4. Times 4 becomes moles of oxygen atom. Use a calculator, you can easily get 0.755. So your choice will be B. Okay. Question 2. Ask you how many oxygen atoms in 51.4 gram calcium sulfate. So tell us mass again, but this time is not more, it's also you number of atoms. Then we need another half. From mass to mole first, then from mole to number of atoms or molecules, right? So mass, the more multiplied by Avogadro number, you get a number of atoms or molecules. Avogadro number Na, I provided on the top of this sheet, 6.022 times 10 to the third power, right? So according to this, the mass first convert to mole, so 51.4 gram divided by molar mass. Again, use this formula. 40.08 is calcium, sulfur 32.06, oxygen 16 times 4. So we get more of calcium sulfate, but here also is oxygen atom. So we need to multiply by 4, right? Becomes more of oxygen atom. Then for more of oxygen atom, multiply by Avogadro number is oxygen's atom's number. Right? So your answer, whenever ask you how many atoms or molecules, this answer should be a very big number, right? Here you have 2 numbers, so you do need a calculator. Use calculator, find this number. This will be 9.09 times 10 to the third power. Your choice is C. If I give you only one extreme number, then you even don't need a calculator. So whenever ask you how many atoms or how many molecules, that always be an extreme large number. Okay. Question 3. Calculate the mass of 4.5 mole chlorine gas. Tell you moles after you mass. Then this is very easy, right? In this chart, whenever tell you more after you mass, then more multiplied by molar mass, right? What is the molar mass of Cl2? Take a look at the table. Cl 35.45. Okay. More multiplied by molar mass. Molar mass Cl is 35.45. You have 2. Cl2 is molecular. Use calculator, you can easily get 319. Your choice will be D. Question 5 asks you, how many molecules of NO2 are there in 10 mole NO2? 10 more NO2. tell you more, ask you how many molecules, right? So more multiplied by Avogadro number. Right? This is a very straightforward question. So more multiplied by Avogadro number. 10 times Avogadro number, 6.022 times 10 to the 23rd power molecular per mole. Then times 10, then 6.022 times 10 to the 24th power. This is the easiest question. So your choice is B. Question 5 asks is the percentage of phosphorus in compound P2O5. Whenever tell you a chemical formula, with the help of periodic table, we can calculate the percentage composition for any element. Right? So here are the percentage of P. Then in this formula, you have 2P. What is the mass of P? Use periodic table. Okay. Mass of P. Use periodic table. Phosphorus 30.97, right? So 2 times 30.97. Numerator is 2P. Denominator or element. So 2P 30.97 plus 5 oxygen. Look at the periodic table again. 16, yeah. Then times 100%. To use calculator, you can easily get this is 48.64%. Your choice is C. Again, some of you choose A. A is 40%. How can you get a 40%? 40%, I believe, 2 out of 5, right? Too easy to be correct. Okay. This is a chemistry. This is not elementary school math. How can you just use 2 out of 5? No, this is college chemistry. You need to use this formula. Numerator is there one you need to figure out. This 2P. P's mass is 30.97. Denominator is the whole chemical formula's mass. Okay. 2P plus 5 oxygen. Okay. So this definitely wrong. Question 6. Here is empirical formula of the compound. CH3. And also here is the molar mass of the compound. Thirty grams per mole. Ask you what is molecular formula? we have a good molecular formula. Okay, much better. Do you remember what it means empirical formula? What it means molecular formula? Empirical formula here us symbol is the whole number ratio of atoms from each element, right? While molecular formula tells us exact number of atoms from each element. This is definition. Then what is the relationship between these two? The relationship between these two is just the whole number. Give you an example. If molecular formula is C6H12O6, then what is the empirical formula? Two? Oh, right. How can we get a CH2O? Every atom, every element actually, divided by 6, right? So molecular formula, empirical formula, their relationship is a whole number. Here, for this example, is 6. Sometimes maybe 1. If 1 means these two, empirical formula, molecular formula, exactly the same. Sometimes maybe 2, sometimes maybe 3 or 4 or 5 or 6, like here. Anyway, it's a whole number. So our job is to find the whole number. How to find the whole number? Of course, we need use the condition tells you. Since here tell you molecular formula is molar mass is 30 gram, then you need to figure out molar mass of empirical formula. Here tell you formula. Of course, we can find molar mass, right? So molar mass of the empirical formula will be 1 carbon. What is the molar mass of carbon? Use periodic table. Right? So I need to change it to 2. So 1 carbon, so carbon's molar mass is 12.01, just simply 12. Hydrogen, the 1, you need times 3, 3 hydrogen. Total 15. Molecular formula is molar mass is 30. Empirical formula is molar mass is over 15. Compare them. Very clear. The whole number is 2, right? Whole number is 2. That means the molecular formula is empirical formula times 2. Right? Empirical formula CH3 times 2, then C2H6. Right? Can you understand this explanation? So our job is to find the whole number from empirical formula and the molar mass of molecular formula. So empirical formula is the molar mass from the formula we can get. Then compare this to molar mass. This is a whole number. Then empirical formula times the whole number we just found is a molecular formula. So according to this explanation, your choice for question 6 will be D. Then question 7 is balance equation. The rule is valence element that show up only one time in each side. For this case, nitrogen, hydrogen, only two elements, right? Any one of these only show up one time. So you can balance either nitrogen or hydrogen, doesn't matter. So this, you can see this is the easiest because here, two nitrogen, then here must have two, right? Balance nitrogen. Now balance hydrogen. 2 times 3 is 6. Then you need to put 3 in front. Again, do you remember the rule balance equation? We can only change the number in front of each formula. We cannot change the subscript number. H2, you cannot change it to H3. Okay, so subscript number is fixed. If you change the subscript number, the compound changes. Sometimes no that compound exists. We have some very weird change this. Very weird balance equation. So again, you can only change the number in front of each formula. This number in front of each formula means the quantity, moles. Moles you can change, but you cannot change this subscript number. This number changed, the compound changed, the molecular changed. Okay. Sometimes the number you change does not exist that type of molecular. B. POH react with H3PO4. H3PO4. Okay. Hydrogen there, this acid, right? This is a phosphoric acid. What this is? OH there, that's a base. Whenever you see balance equation is for reaction with acid reacting with base, the critical reaction is one hydrogen ion react with one hydroxide ion produce one water. This is a critical thing for any acid that react with base. Okay. So if two hydrogen are there, they must have two hydroxide ion produce two water. If three hydrogen are there, they must have three hydroxide produce three water. Okay. According to this rule, how many hydrogen are? Yeah, three, right? Then you need three hydroxide. So put three in front. Then three water, right? So three hydrogen ion, three hydroxide ion produce three water. The rest is potassium and phosphate, Q4. Are these two balanced? Three potassium. Yes, three potassium. Q4 is balanced. Okay. So again, next time, whenever you see the reactions between an acid reacting with a base, just think about this. One hydrogen ion reacting with one hydroxide ion produces one water. If two hydrogen, then you must have two hydroxide ion. If three hydrogen, like in this case, you must have three hydroxide ion that produce three water. Okay. The most problem is question 8. Should work to identify which reactant is the limiting region and calculate theoretic yield. Okay. Most problem comes from here. The reaction is aluminum react with Cr2O3 produce Al2O3 and 2Cr. We mix 40 gram Cr2O3 with 16 gram Al. Ask you which one is a limiting region. Which one is a limiting region? Of course, any one of these, right? You need to figure out which one. Limiting region always retin, cannot be product, cannot be product, always left side retin. The method to find out which one is limiting region is you pick any one of this retin to tell you. Then calculate how much of the other retin needed. Then compare the amount that you have. Right? You can pick any one of these two retin. If I pick 40 gram Cr2O3, so if this means if 40 gram Cr2O3 rat, we can figure out the amount of the other retin here is aluminum. We can figure out how much aluminum needed. This 40 gram is mass. Mass always convert to moles. How to convert mass into mole? Here, right? Mass divided by molar mass, you get more. 40 gram divided by molar mass of Cr2O3. Cr2. Cr, take a look at periodic table. Okay. Cr, the molar mass for Cr is 52. 51.996 is 52. O, 15.9994 is 16. Okay. So from periodic table, we can easily find the molar mass. So Cr is 52. Oxygen is 16. Add them together. 2 Cr, 3 oxygen. Mass divided by molar mass, we get moles. Then use the balanced equation. Every one mole, no number means one. Every one more Cr2O3 need 2 more aluminum. Then the question is where you put the 2, where you put the 1. Two in top or in bottom? Yes, in top, because we want to find out how many moles of aluminum. Of course, put it in the top. In this way, we convert more Cr2O3 into more of aluminum. But this is not the final, because here tell you aluminum is gram, is mass. So we need one more step. Convert this more back to mass. More back to mass. More multiplied by molar mass, right? What is the molar mass of aluminum? Again, use the periodic table. Aluminum 26.98. 26.98. This mass number comes from periodic table. So we get aluminum needed is 14.2 gram. And we have 16 gram. So the amount needed is less than the amount we have. What does this mean? Aluminum is excess. We have too much aluminum, right? Aluminum is excess region, so other left hand is the limit. Okay. Now, next step, calculate the theoretic yield. Now you don't have choice. You must use a limited radian to calculate the theoretic yield. Okay. So limited radian is Cr2O3, and we must use Cr2O3. Mass convert to mole is ROAC. Same thing here. 2 times 52 plus 3 times 16. Mass convert to moles. Then what it takes? Use balance equation. Okay. Every 1 more Cr2O3 produces 2 more Cr. 2 more Cr is we want to find out the theoretic yield of Cr, so this 2 must be in top. And 1 more Cr2O3 in bottom, so we can cancel this Cr2O3. We have not finished. This is only more of Cr. Theoretic yield is mass. So more back to mass. More multiplied by molar mass, right? You need to multiply by 52. This is molar mass of Cr. Use your calculator, you can easily get 31.5 grams. This is the theoretic yield. Second step, ask you, when we mix this aluminum 16 gram with 40 gram of Cr2O3, we actually only get 23.5 gram. This is actual yield. This tells you. Actual yield always tells you. Because we need to run experiment and collect the product. You cannot do any calculation. So if the actual yield is 23.5 grams, what is the percent yield? Percent yield equal to actual yield divided by theoretical yield times 100%. Actual yield tell you 23.5 grams. And the theoretical yield, we just calculate 31.5 grams. It's 74.6%. Here, okay. Do you have any other question? For the quiz 3?